And he's ready here with his presentation, How Can Generative Design Contribute to More Sustainable Solutions? Please welcome to the stage, Krzysztof Wojslaw.
Hi, I'm Chris, and actually today morning I changed the name of my presentation. It's supposed to be How Generative Design Can Contribute to More Sustainable Solutions, but it's not about technology. It's about designers, it's about architects and engineers. So that's why I changed it to How Computational Engineers, Computational Designers Can Contribute to More Sustainable Solutions. And the definition of computational designer is really blurred. There is a computational designer connects two words. In the one side, we have the engineering part, architecture part, creative part. The people who know really how to design things. On the other side, we have programming. We have developing scripts, we have hacking, but it's not about computational design, it's not about hacking, being 100% into developing scripts. It's, as I said, connecting two words. And as David made the introduction, visual programming is one of these low bars that we can go with programming. And computational engineers, people have different opinions and meanings what actually computational engineer is doing. So for example, if you ask my grandma what Krzysztof is doing at his work as a computational engineer, she will respond, okay, Chris is working at the construction site, wearing helmet, and working with the papers. Nothing of them are true. We, as a computational engineers, we are the last person who will visit the site. We are not wearing helmets and not working with paper. I've been working 10 years in Norway, and now 99% of bridge projects are model-based, so we are not working with drawings. We have also friends who are thinking, okay, Chris is an engineer, and he's also Polish, so he is a MacGyver type. So every time if we're going to renovate some bathrooms, so we are going to call him, he's going to fix the stuff. So this is this engineering part. On the other hand, we have this computational part, developing scripts, making algorithm. And we have this superstition about developer, right? A guy sitting in the basement, just developing with old scripts. Maybe we changed a little bit computers. Maybe there are better computers nowadays. But me, working as a computational engineer, always trying to push forward all the industry. And always showing to contractor my script, like, hey, look, you can just move a slider, check results, maybe save some money, save some time. But always I get response from contractor that all my scripts that I'm working as a play. Just come back, Chris, to your work, come back with the serious work, not just working with algorithms. But for me, working with programming in the ESE industry is like exploring something new. Every time that I'm just even making a small script that saves, let's say, 5-10 minutes of my work, I'm seeing that I'm changing the world. But the truth is that we as engineers and architects, 80% of our work is really boring one. Meetings, referates, quality assurance, and just only 20% we can just play and have fun. So in today's presentation, I'm going to show you how we can change this ratio, 80-20, to have much more fun with use of programming. As been said, I'm Krzysztof Wojslaw. You can call me just Chris. I've been working 10 years as a bridge designer in Norway. 2 years ago, I started my own company called learngrasshopper.com. Today, on my learning platform, I have already 3,000 engineers and architects from the whole world. And we are together transforming engineers and architects' work into fun with use of programming. For those who are maybe familiar, I'm also Beam Corner founder, where every week we try to post new things about new developments about Beam technology, especially in Norway. I'm also connected with the university. I really like to spread knowledge at the NTNU, Norwegian University in Trondheim. we have lectures about Grasshopper, about Python, and C#. And it's really game-changing when the new engineers, new generation of engineers are coming to work and already from the first day starting to apply Python and Grasshopper scripts. And I try to teach Grasshopper in the fun way, so it will be more interactive. I really have this feeling that gamification of all the tasks, all the exercises, it's just giving motivation to all students. And coming back to the main topic, AI is everywhere. And many people think that it's a really straightforward way, okay? We are in the point where we have AutoCAD, and finally we have ChatGPT. We have all these 1,000 tools of the AI, and it's straightforward. But the truth is that it's more complicated. There's many stages that we have to do as designers before. And in our industry, we still lack of the data that I'm going to talk about. And second reason, the second thought that is really wrong among designers is that why we should learn programming. Since we have ChatGPT, we can just write to Chat, hey, can you create me a Python script that will change some parameters, and in just 5 seconds, we will get the answer. But the thing is that we have to know programming a bit. We have to know some fundamentals, some basics, to leverage this with the AI. And I really like this quote. AI can be a good multiplier on your engineering or programming skills. But if your skills are 0, then you can multiply it as much as you can with no effect. And it really says how we can use AI tools. You already had this introduction, what is parametric design. But today's presentation will be about generative design. It will be about next level after parametric design. So parametric design, for those who are not familiar, I will show you some more cooking example where we are having our chocolate cake. So in parametric design, as designers, we are defining our recipe, and we are using that. We have some parameters, defined parameters, and it is as an algorithm. We are creating a cake. In generative design, it takes it further by suggesting to us, as working in the kitchen, and we have to define our boundaries. How this cake is supposed to look like or taste. Less sugar, more fluffy, or last least spend money. And this is really a great definition of generative design, that we as designers, at the end, we have to decide what cake we would like to achieve. And we will see the optimization definition. So what does it mean to optimize? Is to make something as good as possible to bring a process or a system to an optimum under a given condition. And especially this last sentence is really important. It's not that AI or some technology is going to just create the design for us. We, as engineers, designers, architects, we have to set up these boundaries. And many engineers have different opinions about what is optimum solution. For some of engineers, most optimal solution is like, for example, we have a beam, and we have utilization of a beam, that this beam is used for 100% capacity. And in one point, this is optimal solution. We are spending less money for the cross-section, so we are optimizing that. But actually, I don't want that at the end of the day, my construction will look like that in the maybe 10, 20 years, I would like to add some extra forces, and actually, I have to redesign whole my structure. So let's start with the generative design. Here on the right side, we have a Grasshopper script. On the left side, we have Rhino visualization. We have really simple foundation that are defined by 3 parameters. We have length in 2 directions, and we have the height. As a one parameter, we have the central force for the column, and we have the ground capacity. In this case, we would like to optimize the shape of this foundation. But we, as the designers, we have to define what will be optimized. So we need to define new parameters. We have to define the price for the concrete, price for the steel, CO2 emission for kilogram of steel, and concrete. Now we have the Octopus is a generative design engine, and we are clicking Start button, and we are going through thousands of iterations. We are checking all the solutions between boundaries, and at the end, we have hundreds of solutions. On the one of the axis, we have the cost. On the other axis, we have the CO2 emission. And when we look closer, we'll zoom to the solution, we'll see that when we are crossing the axis, in the crossing of these axes, we'll find out the best solution. So this is the first reason why we should use generative design, to minimize the stress in our construction. But the second reason is to reduce stress in our work. Architects and engineers, there has lots of responsibility in work, and of course, we have lots of safety factors, safety rules. We have the senior quality check. But I really like this meme that actually shows the idea of our work. Who said that the designer jobs is stressful? I'm 30 years old, and I'm just great. I know that, of course, we have all the safety rules, but there's some disasters, some construction are collapsing, so we have to keep it in mind. So using computational power to go through hundreds, thousands of iterations, thousands of forces that can go, forces combination can actually relieve stress in our work. I'm a bridge designer, so I have to show you one of the bridge design examples. So in this case, we have a Grasshopper connected with the finite element software called Karamba. In this case, we have a bridge design in two types. First one was a beam bridge with lots of columns between in the river, and the second one is an arch bridge. So every time we are going to change this parameter, change the road line, change the radius, the length where this road line should start, and we are calculating the new bridge type. So we are not just checking 2, 3 types of the bridges, we are checking actually thousands of bridges. And again, we are starting, it's not AI, it's just a generative design. So actually, computer is changing all the sliders for us, and we are saving results. So again, we are creating thousands of iterations, calculating every time new type of a bridge. And after a couple of minutes, we will see that's just the arch solution we're choosing. So here we have just idea, okay? Maybe the beam solution for the bridge in this case will be not a most optimal. Last example that I would like to show you, it's work of my colleagues from Norwegian University and some of my students that are supervised. Is called structural circle. The oldest building is based in Oslo, is built with reassembled timber. So timber, in this case, was gathered to the workshop from different places. And first thing we have to do is to sort it out, which timber is good to use, and then scan it. Scan it into 3D to obtain that in this visualization and how we can reuse. So in this case, we have this script that first, it's taking all the scans into the digital world. The next one, we are taking all the dimensions. So based on the scan, we are finding what kind of representation it will be in our structure. So we are taking all the dimensions for length, width, moment inertia for calculation. The next step, we are going to splice every single element. For example, we have 10 meters beam. We would like to splice it, so we reuse for the construction. So on the right side, we'll see the algorithm that is actually step by step, beam by beam, is splicing all the elements that could be reused. The next part, actually the fun part, we are using here the Python scripting inside the Grasshopper. So actually, we are not go directly for text programming. We are still in this friendly environment, and we can just write Python algorithm that actually finds out the elements that can be reused in our building. And in this case, 80% of the elements that we find out from the different construction places were reused on that project. And I'm really happy with this kind of open source project. So this is the link for the research analysis. All the matching algorithm you can find out on the GitHub. Just download it and use it. And actually, this is a point to develop our industry. Today, AI creates amazing scripts for Python, C#, C++, all the different languages. And the reason why is because IT sector has been sharing their knowledge on the daily basis. Last 20 years, all the people were gathering together on the forums, sharing their knowledge, sharing their scripts. We in the AAC together, we are still closed. There is not much work sharing. Of course, there are some company policies, but still missing the place to share it. So from this place, I really encourage everyone to be more open, to work with the open formats, and also share their work with other community. So coming back to the first slide. So next time, if someone will come to me and ask, hey, Chris, what actually a computational designer is working with? So with the clear heart and clear consciousness, I would like to answer that we, as a designers and engineers, we all contribute to more sustainable solutions. That's all for me. Thank you very much.